Thank you very much once again for this great opportunity to present my case today for the Continental League. I'm very honest and very happy to be here today with you. And the topic is today of my lecture, of my case actually, is with the case series we did together with Professor Tomas Linkevičius. We want to find out which of the bone materials might be the best preference for us. Is it xenograft, is it allograft, or is it synthetic bone material? And why? So first of all, I looked a little bit at the literature and I saw interesting cases, but lots of them saying that xenograft and allograft basically have the same features, and basically we're going to have the same result and same outcome at the end of our treatment. But this one, which was done by Pierre Gall and the colleagues, was interesting to me because they used 50% of the autograft of autogenous bone and 50% of allograft in the group A. And in group B, they used 50% of the xenograft and 50% of the autogenous bone for vertical ridge augmentation procedure. And after the treatment, while they evaluated the histology of those bones, they get that they have the vital bone of 60 to 67%. And this was surprising for me, because in the study, we see that we're using 50% of autogenous bone and then mixing with allograft and xenograft, and at the end, we're having 10 or 17% more bone. This is quite surprising, but it's not surprising because we've done this case series and we barely see probably the same results, which I would like to share with you today. So why we need synthetic bone, xenograft or allograft? Because we're having spaces like this during the immediate implant placement procedures. And especially myself, I don't like to leave the places like this without covering them with something. I just doesn't feel myself safe in situations like this. And that's why we're using these kind of the materials. But the problem, why we raised this question and why we did this study is because 5% of our immediate cases we've done, we have not osseointegration, but fibrointegration, and we lose the implants. And the question is why it's happening. The one hypothesis we've done that probably these not soft tissue, but fibro tissues is forming because of the bone we're placing into between the holes and implant. Let's check how it is, actually. So we want to test xenograft, allograft, and synthetic bone materials. And we want to evaluate them clinically, radiographically, histologically, and bone formation potential. And this is going to find from the histological evaluation, we're going to count the percentage of the granules, osteoclasts, and blood vessels. So first of all, we've placed 15 implants, Megagen Blue Diamond. Under the protocol, we're placing implants 3 millimeters deeper and covering them with one of these bone materials. We try to have the granules the same size because it's very important in the process of the remodeling of the bone. Okay, so the second step, we want to see how they look radiographically, how they look clinically after 3 months, how they look histologically. Then we mark them with the special markers in the histologically to find the vessels. They are in brown here, in the brown color, you can see. And then with special markers, we mark them, the same samples, we're marking them with special markers and see the osteoclasts as well. They're now surrounding the granules. So the first case I was showing in the National League, but it's like a continuum because I want to show all the bones. That's why I want to repeat a little bit fastly this first case. This is the healthy woman, 60 years old. We placed the implants in region 34 and 36 and covered them. One of them we covered with the allograft, another with synthetic bone. Allograft, we used Eris, as I already mentioned, and the 36 tooth we covered with the matrix-sized synthetic bone material. So under the protocol, we raise the flap, we place the implants 3 millimeters deeper, we're covering them with the allograft synthetic bone material, another tooth, we're suturing everything, and we evaluating. This is how it looks on the radiographic. It doesn't show us any important information, but for the curiosity, we see that allograft looks more close, the picture more closer to the natural bone. After 2 weeks, we remove the sutures, and after 3 months, this is surprising because we barely can see the areas we placed our implants. And at the beginning, I thought, okay, we're going to take the histology and we're going to see the newly formed bone. We took the histology, the samples for histology. We always trying to take a part of the healthy bone and a part of the particles we placed in order to see the difference, how the bone looks like. This is how it looks after we took the biopsies, the healing abutments, we scanning, the final restoration in the mouth, and X-ray just for the control. And then histology. We already done more than 30 histologies. In this case series, we evaluated 15 using those 3 bones that I already mentioned, but in total, we already going further with our case series using different bones. I will show you later on. But now talking about those 3. So ATIS allograft in all 5 samples, what we're getting that we find the vital bone, which we took, just a part of it with the tryphan, and we're taking the part where we placed our granules. And in the part where when we placed our granules, we're having the granules surrounding by the fibrous tissues, the granules surrounding also with the osteoclast, and we're having a newly-formed blood vessels inside, but no newly formed healthy bone in these samples. No bone yet. After 3 months, we don't have any bone. In the alloplast, we have the same results, where we take the part of the wealthy bone, so we can see it's very nice bone matrix, but inside where we place our material, our bone substitutes, we see only the granules surrounding by the osteoclast. Between them, we see the fibrous tissues, we see blood vessels, but no newly formed bone or a modeled bone, no bone there. Okay, another case, this is the case for the Continental League I chose as well to show how the bone is forming and what results we're getting. The patient, 38 years old, and we need to place implant tooth number 35, 36, and we're going to place tooth number 35 with the xenograft and 36 with the allograft. Again, for the xenograft, Megaos bovine, for the allograft ATIS, opening the flap, placing implants 3 millimeters deeper, covering with the xenograft and allograft, suturing, X-ray after. We can see again, allograft looks a little bit more similar to the bone. Xenograft is wider. After 2 weeks, we're removing the sutures. After 3 months, we're raising the flap, and again, we see a very, very nice picture. And again, I think, okay, we're going to take the histology and we're going to find the bone over there. So we're taking the histology, again, a part of the vital bone and a part of the particles we placed, healing abutments, scan bodies, final restoration on the top X-ray just to evaluate, and the histology. Again, 5 histologies were done with the xenograft. The sample is the same after 3 months. We have a vital bone we took, a part of it, and in the middle where we placed our particles, we're having the particles surrounded by the fibrous tissues, osteoclast surrounding, and the newly formed blood vessels inside. No bone, no vital formed, newly formed bone over there. And this is surprising for us because according to the protocol, what we're using in the practice today, while we're doing the immediate implant placement, we place the implant, we fill the gaps with the artificial bone material, we place individual healing abutment, suturing everything, and we think that after 3 months we can again load our implants. But as our histology evaluation shows that after 3 months we cannot find any bone over there. And probably the reason why in 5% of the cases of immediate implant placement, we're having the failures and not osseointegration by fibro integration of the implants, the hypothesis might be that probably the reason might be this. We're working on that. It's not that we declare this. We're working on that, and we try to answer to these questions to ourselves. And the second thing that we already changing a little bit the protocols in the clinic of how we're doing the immediate implant placement at the moment. This information changes a little bit the protocols. Okay, so now we counted everything, and the results we've got. Synthetic bone material in the samples, we're having 31% of the granules inside. We measuring 5 square millimeters. So that means that we try to take the region only where we place the granules. So in this region, in the synthetic bone material, we're having 31% of the granules, 9 osteoclasts, and 0.13 vessel. In the xenograft, we're having 25% of the granules, 1.95 osteoclasts, and 0.2 blood vessels. In allograft, we're having 21% of the granules, 8.6 osteoclasts, and 0.27 blood vessels. So according to the results we've got, we can now conclude that allograft probably has the best potential for new bone formation because we have less granules, we have more osteoclasts, and we have more blood vessels, which supplies our new formation of the bone. But from allograft and xenograft, they are very comparable. Probably the results not very different from each other, but still the results what we've got, allograft probably showing the best results by now. Then okay, we said we checked free bone materials, but how the real bone reacts. So we took the sample from the real bone. We were placing the implant, and we're taking some bone particles from the drills, and on the same protocol we covered with the autogenous bone, and after 3 months the result is on the left side. We're having the same picture as we had with the allograft. We can see the granules, simply the granules are the autogenous bone, and they are also surrounded by the fibrous tissues. So clinically, not clinically, but histologically, those pictures are quite similar. So what we decided to do next, while we still do not having the fully mineralized bone matrix, but we having the pictures like this in the autogenous bone, in the allograft, in the xenograft, we extended the time by now. So we're doing in the same protocol everything, just leaving the samples for a longer time, 4, 5, and 6 months. And these results we're going to have in autumn. Probably we're going to be ready to show these results if I'm going to pass this selection today. So what we are willing to have at the end of the game, at the end of the day, clinically, we want to have a result like this, and this is our wish and will. So probably I was quite fast, but today is everything what I wanted to share with you. And if you have any questions, would be very happy to answer to them.